Hi everyone. So as mentioned, this week we're going to start work with Python. And to do this, we're going to actually just start by looking at our New York City city bike data, the work that we've been doing first in Excel and then in OpenRefine, and see how that we can scale this by working with Python. So one of the things that I want to emphasize here is that very often for us, Python is going to be not the tool that we use to explore our data, but the tool that we use to process it once we kind of know what we're doing. So in general, I would recommend that, using even text formats or OpenRefine or Excel is a good way to kind of get a look at your data initially and see what's going on. Python, again, is a scripting language. So it's not going to sort of show you a view of what's happening. It's just going to let you do manipulation at a scale much more efficiently than some of those other programs. In order to get started here, we're going to need someplace that we can write our Python code. And the editor that we're going to be using for this class is Atom. Atom is free and open source. It works across platforms. So, you're more than welcome to install it. We're going to be working in Python 3.7 if this is something that you want to try on your own computers. Python also is free, of course. So like a lot of code editors, Atom can edit code for a number of languages. And so one of the first things that we want to do is indicate to the program the language that we're working in. And I find that the easiest way to do that, I'm just going to close out of these sort of welcome windows here, start with an untitled file, is actually just to save our file with the file extension that indicates the language that we plan to be writing in. So in this case, I'm just going to save this, and I'm just going to call this citybike parser.py. So py is the file extension that indicates a Python file. And what this does is it lets Atom know, it lets the program know that it should be detecting, it should basically be doing spelling, really grammatical checking that is compatible with the Python language as opposed to, say, JavaScript or PHP or something else like that. And so in order to make sure everything is working all right here, I'm just going to start with a really basic print statement. This is the classic, when you start any programming activity, is just literally print hello world. And then the question is, how do we actually run this code? So there are a number of different ways that one can do this. Some of you might have been exposed to something like Jupyter Notebook, which actually runs in a browser window and has sort of an interactive interface for running code. There are also so-called IDEs or integrated development environments that package running the code and editing the code kind of all in one. We're going to go very back to basics here, and we're just going to use the terminal window. So if you just search for terminal on your on a Mac, you will come up with a window like this. Very bare bones, as you can see, sort of the traditional look of very old school computers. Now, the thing to point out here is that because this is a text-based interface, I can't point and click my way to the right directory, right? So I actually have to use text commands to move around my computer from the point of view of terminal. So the default place that terminal opens is going to be in your user window, in your user directory. And so the first thing that I want to do is change directory. So I'm going to say cd and type desktop. Now what I did there is I hit tab, and tab will autofill the remaining letters of any folder or file as long as you've given it a unique sort of initial set of letters. So CD is for change directory. I hit enter. Now you can see by looking at this part that I'm on my desktop. So I am keeping my files in a folder called data2. So I can CD data2. Okay. And ls is the list command. So I hit ls and then enter. And it shows me what's available. And obviously the things that have file extensions are files. Backup is a folder that I created. All of these are things that I could easily see in my Finder window as well, right? You can see this is actually just a textual representation of what exists on my desktop in the Data2 folder. So realize that this is just a different way of navigating your computer. This is the way that Terminal has to do it. But it's exactly the same thing. So I can create a file, using the sort of traditional, or a folder using the new folder method, and it will be quote unquote visible to terminal, and vice versa. I can actually go ahead and say mkdir is make directory, and I could say week 4. Is this week 4 that we're heading into, right? and you'll see, almost like magic, a week 4 folder appears in my data 2 folder. Okay, so a little bit of navigating via terminal there, but the main thing here is that we want to make sure that in order to run our Python code, we need our terminal window to be in the same directory as that Python file, right? So again, I'm going to do an ls just to assure myself that I can see, quote unquote, see that citybike parser file. And now all I have to do is run the command Python 3. The 3 at the end is to indicate that we are working in Python 3 as opposed to Python 2, which is actually coming to its end of life very soon, but was very, very popular for a long time. And again, I can start because there's only one file in here that starts with CITI. Capitalization does count, so make sure that you are accurate with your capitalization. And if I hit tab, it's just going to fill in the rest of that for me. And if I hit enter or return here, I just get it to print hello world. Okay, so that gives me some confidence that, you know, my version of Python is installed correctly, that my terminal window is in the right place, and that, you know, my print statement is configured is correct. Now let's get down to business of actually doing something we're interested in doing. So the first thing I'm going to insist, which may or may not, which probably won't surprise you all at this point, is that again, with programming as much, if not more so, as with doing other kinds of analysis, documentation is essential. And so the first thing I'm going to do is write an outline at the top of my file. So I can include something called comments in code. In Python, I indicate a comment line by beginning it with a hashtag, or with a hash, I guess. And what that does is it tells the computer when it's reading the program, don't worry about this stuff. This is for the humans, right? That's why it appears grayed out, right? So again, our typography here is going to really help us understand what's going on in exactly the same way when we see in OpenRefine that something that is green is not being interpreted as text. It might be a number or a date, for example. The typography in our code editor is going to tell us a lot about whether it's structured properly, how it's being interpreted. And this, again, just helps us troubleshoot and make sure that we are constructing our code as cleanly as possible. There are always going to be mistakes. That's fine. The lore that I have is that I think it's nobody can write a program of like 30 lines, more than 30 lines or more than 60 lines or something without an error in it, right? That's fine. The whole point is that we're going to be iterative here. We're going to write a little bit of code. We're going to test it. We're going to write a little bit more code. We're going to test it. So you never want to be in a position where you're writing an entire program and then trying it out, because there's so many places that things can go wrong. So you always want to be doing a few steps at a time and testing very frequently. However, the first thing I need to do is decide outline what my program is going to do. And this is even more important in programming than it is in regular writing. It's very easy as you kind of get into the weeds of how to do something in programming to lose track of like the overall goal. So thinking through it first, just like your work with regular expressions, thinking through it first, writing it out for yourself first, will then give you something to refer back to as you're building your program. And it's genuinely indispensable. So I'm just going to write a quick note here to say that this program will take an entire month of citybike data downloaded from citybike website. And I'm just going to hit enter here so that I could turn on text wrapping, but I prefer to just structure it so I can see it all in one window. Located here. And I'm actually going to grab this URL. I could be more specific with the URL, but I'm not going to be right now. And it will filter all the rows so that only one start station ID. Sorry, I'm actually going to word this differently. I'm going to say it will create a new file that contains all of the rows that month that include the start station ID 72. which I have picked out for no particular reason. So that's fine. It's good to have that overview at the top of what I'm trying to accomplish. Now the question is, what do I need to do to actually make that happen? And so I'm actually going to write individual numbered steps. Again, this is going to be really important for giving myself something to refer back to. So the first thing I'm going to do is say first, open the downloaded data file and read the data. Create a new file to write my selected rows to. Whoops. That did a weird fill in. Don't want that. I'm going to have to turn that off. And now I'm going to, I'm going to loop through all the rows in my data file and check if start station ID is 72. If it is, I will write it output file. If it isn't, I will do nothing. Okay, it's important. If I do nothing, I just don't have to do anything, right? If it doesn't match what I'm looking for, I don't have to worry about it at all. If it isn't, I'll do nothing, and then I will close the source and output files. Okay, so there's my outline. I'm ready to go. You're probably thinking at this point, we've been talking about this for 10 minutes and yet we haven't written any code. Believe me, we've done the important part, a very important part. So in the next video, we're going to dive into actually doing the coding. I think you'll see it's fairly straightforward. There are some key concepts that we're going to be addressing: looping and so-called conditional statements, which begin with if and sometimes have an else, but not necessarily. And through that, we're going to be able to filter an entire month of data in probably several seconds at most. So if you think about a comparison to what we had to do to work through it, even in OpenRefine, much less Excel, I think you'll see very quickly the utility of being able to work with bulk data this quickly. So I will see you all back here in just a moment.